Now our motto determine V naught with the help of Thevenin's equivalent, Thevenin's theorem. So how can determine? First of all, we have considered that is X terminal and here Y terminal. This whole circuit converted corresponding to XY terminal into Norton equivalent, Thevenin's equivalent. Then determine VTH and RTH also. So how can do it? First of all, if you do focus on VTH, we have focused on first VTH, which VTH means V of open circuit corresponding to XY terminal. Okay, so make the circuit first. This one, that is 2Ix, okay, and that is 1 kilo ohm, here 1 kilo ohm, okay, and that is plus minus 4 volt, and here 1 kilo ohm, here Ix. Now that is 1 kilo ohm, here 1 kilo ohm, two milliampere, okay, and that is plus minus 6 volt, and this one is 1 kilo ohm. First of all, this one is removed. Why? Because of our motto determined V of OC corresponding to this terminal. Okay, this is X and here Y terminal. Okay, our motto determine V of OC. If you follow this path or if you follow this path. But if you follow this path, then we have unknown voltage. Okay, so you follow this path. Clear? Now that is 2 milliampere, so it is also 2 milliampere. Clear? That is 2Ix, that is 4 volt, here Ix. Now apply loop analysis. I1, here I2, here I3, and here I4. I1 is 2Ix. I1 is loop current I1 is 2Ix. And what about I4? I4 is 2 milliampere. Very simple. Clear? And what about I3? I don't know. So first of all, what about branch current? Both current direction like this one means same. So branch current is I1 plus I2, so plus minus. Clear? Now here that is I3 direction upward, I2 direction downward, so here I2 minus I3. Clear? I2 is not Ix. I2 clear? I2 is not Ix because of loop current also available here, that's why. Clear? Now next one. What about branch current? Here I1 minus I3, I1 direction upward and I3 direction also upward, so I1 plus I3. Okay, now I4 direction like this one, I4 direction, okay, like this one downward, and I3 direction also downward, so here I3 plus I4. Clear or not? So assign plus minus, here plus minus polarity. After that apply KVL in this loop, minus to plus. Apply KVL in this loop, minus to plus, minus 4, plus to minus 1 into I1 plus I2, plus Ix this will be equal to 0. I1 is 2ix, so minus 4 plus I1 is 2ix. What about I2? Simply put here I2 and plus ix, this will be equal to 0. So 4, this will be equal to 3ix plus I2. Equation number 1. Now apply KVL in this loop. Plus 2 minus I1 plus I3 plus I3 plus I4, okay, plus 6 minus 2 plus ix, this will be equal to 0. I1 is 2ix. What about I3? I don't know. So I3 plus I3, 2I3. What about I4? I4 is 2 and here 6, here ix, this will be equal to 0. Clear or not? Very simple. I1 plus I3, here I3 plus I4 plus 6 and here minus 2 plus ix. Okay. So that is ix, simply ix plus 2i3, this is equal to minus 8. Okay. Now our motto to determine I3. So this ix value put here, then we got 4, this is equal to 3 into ix is written as minus 8 minus 2i3. Okay. Now this value put here, then 3 into minus 8 minus 2i3 plus i2. So 4, this will equal to minus 24 minus 3 to i3 plus i2. Okay. And what about i2? I1 is 2ix, I4 is 2. Now after that, for 28, this will be equal to I2 minus 6i3. That is equation number 2. Okay. I know that ix is also written as I2 minus I3. Okay. If this value put here, then minus 8 minus 2i3, this will be equal to I2 minus I3. So what about I2? I2 is written as minus 8 minus I3. If this value put here, 28, this will be equal to minus 8 minus I3 minus 6i3. So that is 36, this will be equal to minus 7i3. So what about I3? I3 is written as minus 36 by 7 milliampere. Okay, now apply KVL in this loop. Minus 2 plus minus V of OC plus 2 into 1 plus I3 plus I4. I3 is minus 36 by 7. And what about I4? I4 is 2 and that is 6, this will equal plus 6, this will equal to 0. So V of OC is written as 2 plus 2, 4, 4 plus 6, that is 10. 10 minus 36 by 7. (36) divided by 7, that is 5 point something, minus 10, we got 4 point, that is 4.8571 volt. That is V of OC. Okay, that is V of OC. So V of OC, finally we got or VTH, that is 4.857 volt. Okay, simply apply, we'll take loop current I1, I2, I3 and I4 and then apply KVL all loop, then determine V of OC, that is 4.8571 volt. After that, first of all make it, after that we are making corresponding to, we have focus on RTH. Now next target is RTH. How can determine RTH? All independent source reduced to be 0 first of all. So make the circuit, that is 2Ix, and all independent source, that is independent, this is also independent and this one is also. So 1 kilo ohm, here 1 kilo ohm, here short circuit, here 1 kilo ohm, here Ix. And that is open circuit. Okay, and here 1 kilo ohm, here 1 kilo ohm. Now that is current dependent, current source available. So we have taken 1 volt voltage source or 1 ampere current source. If you consider 1 volt 1 ampere current source, then what about voltage V? So our focus on V is equal to 1 into RTH. So basically our motto, RTH is nothing but it is V. If you determine V, then we got RTH. All in kilo ohm. That's why we have considered 1 milliampere. Then answer is in kilo ohm, because of V is in volt and this one is milliampere. Then what about RTH? RTH is in kilo ohm. Then possibility. Okay, so how can do it? First of all, here Ix. Now if you consider loop current I1, here loop current I2, here loop current I3, and here loop current I4. Clear? So first of all, what about I1? I1 is written as 2Ix. Clear? I4 is written as 1 milliampere, that is 1. Clear? Now what about branch current? Here I1 plus I2, very simple, plus minus. Now here Ix, if I2 is greater than I3, then here I2 minus I3. Now here I1 plus I3. Okay, if this one is stronger than this one, then here I3 downward and I4 also, so I3 plus I4, and here I4. Clear or not? If you determine I3, then we have determined also V, because of apply KVL in this loop in very simple way. So how can do it? First of all, apply KVL in this loop. I1 plus I2 plus Ix, this is equal to 0. Very simple. Apply KVL in this loop. I1 is 2Ix and I2 plus Ix, this is equal to 0. So what about I2? I2 is minus 3Ix. Clear or not? So we got I1, I2 and I4. Now apply KVL in this loop. Here plus minus, first of all assign sign. Plus to minus, I1 plus I3 plus I3 plus I4. and minus 2 plus minus ix, this is equal to 0. Okay, I3, 2i3 I1 plus I4, I1 is 2ix, I4 is 1 and ix, this is equal to 0. Clear? Clear or not? Our next target is determine I3. How can you determine I3? 2i3 plus ix, this is equal to minus 1, equation number 1. I know that ix is also written as I2 minus I3. If I2 put here, then we got minus 3i3, I2 minus I3. I2 is minus 3ix minus I3. So what about I3? I3 is written as minus 4ix. Okay, if this value put here, then we got 2 into minus 4 ix plus ix, this is equal to minus 1. So that is 8 minus 8 plus 1 minus 8 plus 1, that is 7 ix. So ix is 1 by 7. If this value put here, then what about I3? I3 is minus 4 by 7 milliampere. Our target is corresponding this one. Apply KVL in this loop, that is I4 plus I3 plus I4, this is equal to 0. So V is written as, what about V finally? I4 plus I4, that is 2 times I4, so 2 into 1, that is 2, and I3 is minus 4 by 7, so that is 14 minus 4, 14 minus 4, that is 9. Okay, so how can solve it? First of all, that is 14, that is 10 by 7. Okay, so 10 divided by 7, that is we got 1.428. Okay, 428. Okay, so what about RTH? RTH is V, so that is 1.428 kilo ohm. Clear or not? Okay, RTH is 1.428 kilo ohm. So finally make the circuit plus minus, here RTH, here VTH, here RTH, here RL, here X, here Y. VTH is 4.857 volt, and that is 1.128 kilo ohm. And what about RL? RL is 1 kilo ohm. So what about V0? Our motto, determine V0. So V0 is RL into VTH divided by RTH plus RL. Put this value. Okay, after put this value, that is RL is 1 into 4.857 whole divided by 2.428, and we got closer to 2. Okay, closer to 2, you can say that is 2 volt. Or if you find more closer, then 4.857 whole divided by 2.428, then we got 2.00, closer to 2, bold. Final answer. Okay, so final answer is, that is answer. Very simple. First of all, we have focus our motto, all RTS, all independent source reduced to be 0. So if all independent source reduced to be 0, that is short circuit, that is short circuit, that is open circuit. After that, our next target is determine V, Thevenin's voltage, Thevenin's resistance. So how can you determine Thevenin's resistance? I know that if you consider there is current dependent current source available here. So if you current suppose that is 1 milliampere corresponding to, that is V volt, then taken loop current I1, here I2, here I3, here I4. Okay, first of all, same I1 is 2ix, I4 is 1 milliampere. Clear? Now apply KVL in this loop. We got I1 plus I2 plus, here apply KVL in this loop, I1 plus I2 plus Ix, and after that put this value, and we got I2 this equal to 3 times like this one, and after that apply KVL in this loop, then we got this one. Okay, after that this value put here, I2 this is equal to minus 3, and I3 is 4 times Ix. I know that. Clear or not? After that this value put here, then we got Ix, and if this value put here, then we got I3, and apply KVL in this loop, then we determine RTH V, and V is also RTH, so 1.428, and put this value corresponding to VTH RTH, and here RL, then determine V0 with the help of voltage divider rule.